Hello there! This video is part 2 in my series in which I am extracting neodymium from neodymium magnets. I have found an amateur-friendly way of making neodymium metal, but don't get your hopes up because it's very inefficient and straight up terrible. So, here is how I did it. Very unlike myself, I actually properly planned this one out. It was a two-step process. First step was converting neodymium oxalate to neodymium oxide. This shouldn't be and wasn't a problem. Can't say the same for the second step, which is reducing the oxide to metal. You see, neodymium is more reactive than aluminium, so I can't use that. I had to do a bit of math to see if I could use magnesium. I can, but it's not ideal. Ideally, I would use something that would release enough energy to melt the reaction mixture on its own, but because the most reactive thing I had was magnesium, I had to find a workaround. I decided to use the same trick that is used in silicon thermite. That is to add additional metal fuel and sulfur. The reaction is very good for supplying heat, but there is one problem. Magnesium sulfide produced in reaction can react with water to produce hydrogen sulfide, which is a toxic gas, almost as bad as hydrogen cyanide. Oh, and it also smells like rotten eggs. I weighed out a bit of neodymium oxalate and heated it with a MAB gas torch until it decomposed. The mass was reduced by roughly 50%. Once I have prepared neodymium oxide, I combine it with magnesium and sulfur. I probably should have used fine powder instead of granules. I used a ratio of 1 part neodymium oxide to 0.434 parts magnesium to 0.286 parts sulfur. When the reaction products cooled down, I broke up the mass and found some small metallic bits. Produced metal quickly tarnished in air and there really wasn't a lot of it. Judging by the color of the slag, most neodymium metal reacted with oxygen and converted back to oxides. In hope of better results, I scaled up the reaction. Color of this batch of neodymium oxide I prepared is basically the same as the color of the slag. I am quite sure that the prolonged glow we see is our product burning in the air. As you can see, the slag is very porous and didn't do a good job of protecting our product from the air. We live in an oxygen-rich environment. I did find some metal pieces, but it wasn't much of an improvement. Feel free to comment if you have any suggestions how to improve this reaction. Thank you for watching. Here's a little teaser of my future plans.